Welcome to ZwitterCo Unfiltered, real talk on membrane filtration. I'm Jon Goodman, Vice President for Food Processing and Specialties, acting as your host, and I'm very pleased to be here at our headquarters in our Technology Innovation Center in Woburn, Massachusetts, outside of Boston, with my colleagues, Leonid Semenihin, who is our commercial engineer in Europe, and Scott Brown, who is our dairy-focused engineer or expert in North America. Welcome. And of course, for repeat viewers of our podcast, Scott's been on before, but with our team together, we wanted to bring on Leonid. So for ZwitterCo Unfiltered, we're going to follow the same pattern as we have in the past, starting with a question that we received from a customer. And then our topic for today is going to be applications that we're working on. And again, with Leonid here, I thought it was going to be a good opportunity to talk about other applications besides just dairy that Scott and I have been focused on. So the question that we received was, tell us more about the outlook for protein. They've been hearing us talk a lot about protein. You know, what's the outlook, and how does that impact you with your customers? So Scott, with your focus on dairy, I thought I'd start with you. What you're hearing?
So in the last 6 months, the primary thing that I've heard is that the demand for protein is going to continue to rise. The demand for protein is expected to rise at 7+% annually. The demand for cheese is only rising at about 2%. One of the things that we're seeing a lot in the field, a lot more of, is MPI and MPC. So milk protein isolates, milk protein concentrates, milk protein concentrates anywhere from 70 to 75, 80%. And then, of course, MPI that eclipses 85% protein.
You know, here in the U.S., we're hearing a lot about GLP-1 drugs. What's going on in Europe?
Good question. Yeah, so principally the population is growing and the protein demand is growing together with the global population. And this is the main change which we see on every market.
Do you find that there's a push for high protein diets?
Definitely, there are new diets and also new products, protein-containing products. So in every supermarket you find a lot of milkshakes of other kind of protein products.
You know, of course, here we've got the Fairlife effect with ultra-filtered milk, and that's been growing. And with multiple dairy companies that are introducing ultra-filtered milk for higher protein. Oftentimes with these ultra-filtered milk, there's less lactose, so there's less milk sugar. In Europe, I often hear about alternative protein and vegetable protein. Are you seeing much of a demand for that?
Definitely. So as resources are limited finally, specifically in Europe, where the European government trying to reduce also their cow population. Finally, so there is a requirement of additional sources of proteins, and the vegetable protein or plant-based protein is one of major sources. There are some specific kinds of protein sources like algae, for example, or other kind of biomass, but principally the plant protein is the mostly important one, and a lot of bigger companies are developing different processes to convert plant-based matter finally into usable protein as main product or supplement into common standard products containing animal proteins.
And I know there's a lot of pea protein that's grown. There's a lot of pea production in Canada. In Europe, the vegetable protein, what is the most common? Is it soy or do you also see pea?
It's principally wild mix. It's also pea protein, soy, so everything possible.
Yeah, it's interesting. Now, obviously, with ZwitterCo, with our anti-fouling membranes, one of the things that I've heard talking to customers is that they actually have greater fouling issues with vegetable proteins than they do with whey or dairy streams. Is that what you're hearing as well?
This is what more major customers are confirming actually, and also the companies developing new processes for recovery of vegetable protein or plant-based protein. That the fouling issue is significantly more important in this area comparing to common applications with the recovery of animal-based protein.
And, our topic for today is different applications. And so I suppose that I've already started moving right into the different applications. So, Scott, you've been quieter than normal. Talking about dairy and demand for protein, what do you think? You mentioned earlier with MPI and MPC, it seems like we're seeing higher protein content. We're seeing more of the isolates. Are you seeing that?
And we were seeing the markets move more in that direction. I was with a customer just last week, and he said that they were focusing their full attention and changing their system to go to whey protein isolate as opposed to WPC 80. And he said that the full force of that company is going to switch to whey protein isolate. And that's just the removal of the fat. So instead of just concentrating the protein in the stream, now we're removing the fat from the stream as well. So we're using an MF or a microfiltration up front to remove the fat. And then we're concentrating the protein to 90% plus. And again, the other thing too is after that, we have to nanofilter it because we can't evaporate it. If we evaporate those proteins at the high temperature, then we're going to denature the protein. So that requires one more step of membrane filtration to get the solids to where we need them, so we can get the solids or the bulk density high enough so we can actually get the product in a bag, which is a very important piece of getting it out into the field.
And that helps when you're selling a powder.
Absolutely, yeah.
What total solids do you typically see for a WPC 80?
WPC 80, we can drive the solids to somewhere between 32 and 34.
And then when you go to the WPI, much higher are they going?
They're actually not going a lot higher. It's just more difficult to get it there. And you got to remember too, if it's just protein, there's no lactose in there to help bind that and create our bulk density. So it's a fine balance to try to get it to where we need it to be.
Are you also seeing demand for the WPPC or Pro Cream?
So Pro Cream, what's been funny about my career is when we started out with the whey problem, right? So then when we were able to solve the whey problem, then we had the lactose problem, right? Because now we've got excess lactose left over. What are we going to do with that lactose, right? And then when we stepped up to the WPI, then it became, what are we going to do with this Pro Cream? And for every step of the way, these intelligent, incredibly smart R&D people that work for the creameries have figured out another process that we can do to make that more saleable and take that to the market. Pro Cream is high protein and high fat. Okay, what creatures really need high protein and high fat? Babies,
Yeah.
right? We want to get those nutrients into infants. High protein, high fat, all good things. Once we can get them dried and we can get them in a stable process where we can actually regenerate it and put it into water, get it back into solution and get it inside of that child, how exciting is that? And we're seeing more and more of these innovations all the time.
Yeah, that's the thing that's always amazing is, as we go into talk to some of our customers in dairy and how they're able to just capture value and make products out of everything. And obviously it all started with cheese and creating value from the whey. But it seems like, we started the podcast, we started this talking about the demand for protein growing faster than the cheese. And so now it seems like there's a growing number of customers who are taking casein or protein directly from the milk with native whey.
Right. And the native whey is a big deal too, because it is, again, more stable. It hasn't been beaten up through the cheese making process. So when we extract that native whey or serum protein, or there's a half a dozen different names that they call this stuff, right? But it is more available to mammal nutrition, which is what we all are, right?
Mm-hmm.
And it's able to be absorbed more easily into the system because it's less denatured. Because during the cheese making process, we beat those proteins up, we make them denatured, and then they're harder for the human body to absorb and assimilate.
Right. So, taking a break from dairy, Leonid, you've been with ZwitterCo now since the middle of last year, and as you've been going out and introducing our product in Europe, tell me about some of the customers, some of the applications they're looking at.
There is a great interest in any area where the fouling can be a limiting factor, both in productivity but also in operational costs.
Mm-hmm.
Some areas which are common for using the ultrafiltration or for superfiltration piecing membranes as a replacement for ultrafiltration is common, like in dairy industry, mainly protein concentration or concentration of any kind of organic matter with high molecular weight, and its purification using diafiltration cycle. And principally, every customer operating the system utilizing similar processes is very interested in our products.
So I know you've been talking to some people about downstream processing. I think that when it comes to the downstream processing customers, when you think about the different categories of customers, I know industrial bioprocessors or industrial biotech was one topic. Who else has been looking in downstream of fermentation?
There is a number of different applications and systems, and principally using the modern biotechnology, it's possible to create any kind of organic matter as a result of metabolism of growing of bacteria or any other kind of microorganisms.
Mm-hmm.
And the mostly known products section from this area, proteins, enzymes, for example, or organic acids, which can be used as a product for the conversion them into further matter. Like, for example, lactic acid can be used for the production of polylactic acid, which can be used as a bioplastic.
Mm-hmm.
Different sectors of industries. But there are a lot of processes where the customers are converting biomass finally, and sugars use it as a feed for biomass in any kind of specific organic matters. And the variety of such products is very wide.
In the area of food or food and beverage, I know that you went to what's it called, Drink Tech in Munich.
Yes.
Yes. That's you must have enjoyed that at going to Munich.
Definitely.
Yeah. The one of the applications that we talked about after that was beer dealcoholization.
Beer dealcoholization is one process where reverse osmosis membrane can be used as an alternative to the conventional process of thermal dealcoholization of beer by using distillation or evaporation. So membrane technology is already established way to dealcoholize the beer. Beer is a very difficult product to filtrate due to the fouling behavior. And this impact not only efficiency of dealcoholization system during the main cycle of concentration, it's also impacting the economics of such process, because the fouling is also causing increasing of the diafiltration water demand finally. And this results in consumption of diafiltration water, but also in bigger amount of wastewater resulting from such process.
I'm going to talk about the diafiltration, and I'm going to ask you a question about that in a second. But I wanted using reverse osmosis to make to dealcoholize beer. What benefits does that have versus a thermal process? Doesn't it make a better tasting, final product?
Definitively. So the major factor for every brewery or for every brewer master is just to keep the taste of the beer like it was in the original condition. And any thermal separation process just by the nature is running by elevated temperature, and elevated temperatures are changing the chemistry of the beer or any other kind of beverage. And this results in changing of taste or odor profile of the beer. And as membrane separation is operating at lower temperatures, so reverse osmosis, it's possible to operate even at 10 degrees C or 2 degrees C or 5 degrees C. Pyrolysis can run at significantly lower temperature and do not impact in chemical way the properties of the beer.
Excellent. And then diafiltration is a major part of that process.
This is the core of withdrawing the alcohol out of the beer.
Are you seeing customers talking about recovering the diafiltration water and reusing it so that they don't have to send that to wastewater treatment?
Definitively. So the portion of diafiltration water can be reused once again. So especially the water coming out of the system at the end of the cycle with a low concentration of alcohol. But also the complete portion can be theoretically used as the brewing water in the brewing process once again. So without sending this into the sewer. Yes, so this is just a matter of changing of the fermentation process finally. Not so easy, but it's possible.
And that would, do you think they would use membranes then to treat that diafiltration water before recycling?
So in the beer dealcoholization process, the reverse osmosis membrane is already used. So in terms of salts or any kind of organic matter, the concentration is very low in the ferment. So it's principally possible to use this water directly as a brewing water in the next cycle.
Yeah, I know a lot of these applications we're talking about, we're talking about fouling during product concentration, whether it be proteins or, I guess the beer dealcoholization process itself. But the water, and that came up in conversation that Scott and I were having yesterday. You were talking about how in dairies, 90%
of the milk that
is
comes in is water.
Yeah.
Yeah. And we want to capture as much of that water as we can and reuse it. And that way we're not taxing the well system or the city water supply. You might as well capture as much of that milk water as you can, cow water, and make it available to CIP in the plant, for diafiltration in the plant. There's a multitude of uses for that water.
Yep. Yeah, it's interesting. I perceive that the dairy industry is probably reusing more of their water just because it's in the raw material. I think that the dairy industry seems to be reusing more of it than some of the other industries. I've had conversations with people involved with vegetable proteins, pea protein, soy protein processing, and they're sending the diafiltration water to drain.
Sure.
So that's still an area that I would expect over the next few years we're going to see more and more growth in. And the biggest problem, when I've talked to people, why aren't you recovering it, is just
Flavor
foul.
profile. And flavor profile is a huge piece of that.
Well, and I've actually talked to people, actually a couple of different companies about recovering aroma or flavor from water. And they don't always tell me where the water is coming from, but I'm assuming that it's diafiltration water.
Sure.
So interesting. Well, thank you very much for the comments. We talked about a number of applications. Dairy is the largest food application, but there are dozens of other industries. Heck, we should have another podcast and talk about starch applications at a later time, sweetener and starch applications as well. So thank you for tuning in, and please send comments and questions, and we'll address those on future podcasts. All of the podcasts, as well as webinars that ZwitterCo puts on, are available from the resources page on our website. Thank you very much.